Welcome to Straight Talk with Supply Chain Insights. My name is Laura Cesari. I'm the founder of Supply Chain Insights, and today I'm interviewing ThinkIQ in preparation for the Supply Chain Insights Global Summit. Doug, welcome to the show.
Hello, Laura. Thank you for having me.
Doug, tell the group a little bit about yourself.
Laura, I've been working, in startup companies making manufacturing software for the past 20-something years, and have really been, very fortunate that the products that my companies have created are now in use in about well over 1 million different facilities all over the world. So, I've been living and breathing supply chain and manufacturing from a vendor's perspective for the last 20-odd years. And about 4 years ago, we started ThinkIQ really with a view to saying, let's see if we can imagine a very different way of doing supply chain software and see if we can come up with something innovative and potentially transformative.
Well, Doug, what is it that ThinkIQ does? If we had to just really shorten that value proposition, what do you do?
So we start, and the thing that we do, which is unique, is that we're able to take data from all of the different sources that are used in a typical manufacturing supply chain. And that includes the sensor data from the control systems and IoT data, as well as the data from the business systems. And we're able to take that data and automatically create a very granular genealogy of how a product is made. In other words, very accurate traceability where you can see every single material movement. In the food and beverage industry, we often refer to that as farm to fork visibility and transparency. In mining, it's often referred to as mine to metal. I met somebody the other day who's in the toilet paper business, and they used the term I'd never heard before, stump to rump. A lot of different reasons, but really creating this very accurate traceability is what we do. And the reason why we do that is that it allows us to achieve 3 goals for our customers. The first is to allow them to guarantee that they get a safer product and they're less likely to have recalls. The second is for us to be able to find the economic opportunities that are occurring up and down a supply chain that have been very difficult to find in the past. And then the last is to essentially make them more sustainable as businesses.
So, Doug, when you think about Supply Chain 2030, which is the focus of the conference, how does this connect, and what do you think is needed for Supply Chain 2030?
When we look out that far, I really think the key about a supply chain in that time frame is that it needs to be autonomous. In the same way that we talk about autonomous vehicles that can drive themselves, the supply chain really needs to be something that works far more autonomously with far less human input than it does today. And that autonomy needs to occur potentially within the physical manufacturing facilities, between the manufacturing facilities, and up and down the supply chain. And the autonomy really needs, in the same way that a car to be autonomous needs lots of cameras, lots of sensors, and lots of really intelligent software that's making real-time decisions. That's what we think the modern supply chain looks like. It's all going to be driven by data coming from sensors that are telling us very accurately what's happening in the physical world. And then we're going to have these very powerful processing capabilities that make sense of that data for humans. So we really move from a world today where you look at most supply chain systems where people are typing data into computers to tell the computers what physically happened in the physical processes. And we think that gets turned upside down completely in 2030, where instead of people telling computers what happened, computers are going to be taking all of the data that comes from sensors. They're going to be synthesizing that and then telling humans where they need to focus their attention in order to be able to deal with conditions that are out of normal and conditions that really require attention that the machine can't take care of.
Well, Doug, we're doing a digital showcase, which means that we're asking folks like you to show their software so that people can get a feel for what this means. Would you mind to go ahead and show the audience your software?
Yeah, I'd be more than happy to do that, Laura. So what I can show today is really a demo system because I don't want to show any of our customers very valuable data, but I'd be more than happy to give you a very, very quick demo of the way that the product currently works today. If you could let me share my screen, that would be great. Thank you. And what I'm going to do is I'm going to start a browser. And one of the great things about software these days, like ours, is that it's all cloud-based, so nothing ever needs to be installed on the end user's computer. And in fact, very little needs to be installed in the physical processes for this to work. So this fictitious company that I'm going to show today is called Acme. And Acme is a typical contract manufacturer that makes products for a whole lot of different companies. And we have a very simplified physical process for Acme. What they do is they make syrup for beverages for a wide variety of different beverage manufacturers. And as in a typical supply chain, there are vendors supplying a whole lot of different ingredients that go into a physical manufacturing process where we have tanks that feed into one another. And eventually we go through a packaging line. And what comes out on the far end of that packaging line is the finished product. And what we do in our product is we take that information and we model it in what's commonly referred to as a semantic model. And the semantic model here, I'm just going to show the process layout. And what you're now seeing is from a computer's perspective, that same model that we saw before, which is really the tanks that receive data from the trucks, and then a physical process that eventually results in finished goods being made. And all of these things have lots and lots of sensor data. So if I click, for example, on this sweetener batch tank over here, I can drill down and I can say, show me what this equipment is doing right now. So I click on the equipment detail, and I'm now seeing sensor data changing in real time. This is the history of the sensors associated with that tank over the last few hours, or actually over the last hour. And if we look at this in a little bit more detail, I'm going to click on this button here, and I'm going to show what the system is recording. So over a period of time, you'll notice that the tank fills and then empties in a series of steps. And we have valves that are opening and closing over any period of time. And we can look at this data. If we look at the last 10 minutes worth of data coming from the sensors, we can see that in a little bit more detail. This is a typical example of sensor data where we're seeing what's physically happening in a plant. Now, human beings can take that sensor data and try to work out what it means, but it's far, far more interesting if the software can actually deduce what happened in its own right. So if we go back to that process diagram, then what I'm going to do there is basically take that same batch tank and what I'm going to do is basically say, instead of just showing me what the raw data looks like coming from the sensors, show me what the system intelligently deduced physically happened in the process. So now what we're looking at is the flow of materials through the physical plant deduced by the sensors. In other words, we're looking for the fingerprint of what caused the material movements. And I can go back into any point in time, so anywhere in history. And what we're looking at over here is that we're seeing that sweetener tank number 1 and sweetener tank number 2 basically both fed information into the batch tank, and the batch tank took information, it went into a use tank, and this is somewhat detailed, but I can continue to navigate all the way through the process where I can see how the sweetener tank then sent data to a bunch of different accumulators, and we're deep down inside a physical process. But from the accumulators, the material then moved to the next step in the process. And what we're looking at here is a completely different view into what's physically happening in a process that's being automatically generated. And how does the system know? What are the fingerprints that the system looked for? If I now click on that trend diagram, what we see now in these blue and orange areas are where the system looked and said, I can see a movement that's relevant over here. and I can see that it's actual material flowing that matters, that we're tracing. These movements didn't move into that flow, but this one did over here. So what you're starting to see in this very, very simple demonstration is how we can create this very, very accurate genealogy of how things are moving through a physical process. This is the data then that we can use to basically be able to look and say, what are the root causes of how something behaves in, for example, if part of your process is behaving poorly, if you're getting bad yield or poor inefficiency, this is the data that we can then go and do the root cause analysis and say, this is the cause of what you're seeing right now, and this is what you need to be able to do to correct it. Or if the process is not working properly, it's what allows us to essentially draw attention to the fact that your physical processes have deviated from what we describe as the happy path. So, Laura, that's a very, very short demo. I just wanted to give you a sort of a sense of how we take the sensor data and really make sense out of it and change it into material movements, which then becomes the kind of backbone of how we do a more detailed supply chain management. Did that help understand the kind of things that we're doing with the data?
Well, Doug, thank you very much. Now, many people might say, well, don't we do this already? But, I find that people have a lot of sensors, but they don't really use them. And at our conference, McCain Foods is actually going to talk about their use of ThinkIQ. Maybe you could just really quickly highlight what the McCain story is going to be.
And yes, I'd love to do that. So McCain is one of our most innovative customers that we have, and McCain have really been using ThinkIQ in their appetizer business, where they make onion rings, and they've also now started using ThinkIQ in their core business, which is potatoes. And what they're really trying to do, first of all, is get this very high level of traceability so that they never have problems with their product, to ensure that it's extremely high quality and that they never have recalls. But very importantly at McCain, they also want to make sure that this pays for itself. And McCain intuited and wanted to prove that there were events that occur in agriculture. In other words, while the potatoes or onions are growing, or whilst they're being stored, or whilst they're being transported, that significantly affect both the quality and the yield that occurs in the physical factories. We're deployed at McCain at scale. So we're collecting data from agriculture, literally information about where the fields are, when the product is planted, when it's harvested, how it physically moves through the supply chain. And when finally the onions or the potatoes are taken out of storage, we track their movement until they make it all the way through the physical plant. And what that allows us to do then is to be able to look and say, for example, in onions, to be able to look and say, when we see that the plant is producing less finished goods from the onion than we would expect it to, what were the common causes that were happening back in agriculture, possibly months or even a year previously? And what that's allowed us to do in the onion business is significantly improve the yield. And it's a fabulous story at McCain, because they made an investment in a system that was intended to ensure better product quality and safety. And it's really paid for itself many times over by allowing them to physically increase the yield that they get out of that supply chain.
Well, Doug, thank you for sharing the story. At the Digital Summit, we will not have any booths or, opportunities like a traditional trade show, but I understand that you will have people there and you'll be able to talk about the solution one-on-one as people approach you.
Absolutely. Yeah, we'll have a couple of people at present. McCain themselves will be there, and we would be delighted to be able to drill into more detail and show what we think is a really transformative way to look at one's supply chain.
Well, thank you so much. Until next time. Thanks, Doug.
Thank you. Bye-bye.
Bye now.